Probability distributions. Many decisions in business, insurance, and other real-life situations are made by assigning probabilities to all possible outcomes and then evaluating the results. Definition: a random variable is a rule that assigns a unique number to each outcome in the sample space. Example: let's suppose we toss a fair coin 3 times. Let's consider the sample space S. In our case, we can have a scenario where all 3 of the coins come up heads, or all of the coins come up tails. That's one possibility. Now we can have the first one being heads and the last 2 being tails, or the first 2 being tails and the last one being heads. We can have heads, tails, heads, tails, heads, 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 tails, and finally we can have tails, heads, tails. So this is the sample space for tossing a fair coin 3 times. Looking at the sample space, I notice for the first scenario there is 3 heads. For the second case, we have there is absolutely no heads. For the third, there's only 1 heads. For the fourth, there's only 1 heads. This one has 2 heads. This one has 2 heads. This one has 2 heads. And this one has 1 head. And that leads us into our next topic. We can let X represent the number of heads that appears for a 3-coin toss. Thus, X is a random variable since each outcome is assigned a number X. The range of X can be as low as 0, and it can go up to 3 heads. We can have a situation where there's no heads showing up, or we can have a situation with just 1 head showing up, or 2, and at most 3 heads showing up for a 3-coin toss. I want you to note the probability of 0 heads is equivalent to 1 out of 8. If you look at our sample space, that's the situation where we have tails, tails, tails. There is a 1 out of 8 possibility that we will get 0 heads. The probability that we get 1 heads is equivalent to 3/8. And that is because that's the situation where we have a heads, tails, 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 heads, or tails, heads, tail, where we only have 1 heads appearing. And similarly, we have the probability of 2 heads is equivalent to 3/8. And the probability of 3 heads is equivalent to 1/8. Now I want you to look at the numbers and ask yourself, what would the total be of 1/8 plus 3/8 plus 3/8 plus 1/8? The total here is going to be equal to 1. The total is equal to 1 because 1 represents 100%. The total of all possibilities must add up to 1 or 100%. The mean, variance, and standard deviation of a probability distribution is given below. The mean is equal to the summation of x times the probability of x. The variance is equal to the summation of the quantity x squared times p of x minus the mean squared. And finally, the standard deviation is equal to the square root of the previous formula. I want you to also note that the mean, standard deviation, and variance are used since we are talking about a population. Example: find the mean, variance, and standard deviation for the number of heads when a coin is tossed 3 times. The mean is equal to the summation of x times p of x. The variance is equal to the summation of x squared times p of x minus mu squared. And finally, the standard deviation is equal to the square root of the previous equation. Let's make a table to do this problem. I'm going to put x, p of x, x times p of x, and then finally x squared times p of x on the last column. Now the reason we put these on top of the column is these are the individual components of the formulas that we need to calculate the mean, variance, and standard deviation. Now we're looking at a coin toss and we're tossing it 3 times, so we have several different scenarios: 0 heads, 1 heads, 2 heads, or 3 heads showing up for a 3-coin toss. On the previous slide, we know the probability of 0 heads is 1 out of 8. The probability of 1 heads is 3/8. The probability of 2 heads is 3/8. The probability of 3 heads is 1 out of 8. And now to calculate the third column, I just need to multiply x times p of x. 0 times 1/8 is 0. 1 times 3/8 is 3/8. 2 times 3/8 is 6/8. 3 times 1/8 is 3/8. Now, to calculate the fourth column, we need to get an x squared times p of x. The column before is just x times p of x, so we need to multiply this by an additional x to produce x squared. So I'm going to multiply this column with this column to get the fourth column. X times p of x is going to give us an x squared p of x. So 0 times 0 is 0. 1 times 3/8 is 3/8. 2 times 6/8 is 12/8. And 3 times 3/8 is 9/8. Now we can find the mean for the distribution. The mean is equal to the summation of x times p of x, and that means I just need to add this column for x times p of x. The summation just means take the total. So we'll add 0 plus 3/8 plus 6/8 plus 3/8 together. And that gives us 1.5. So the mean is equivalent to 1.5 heads. On average, we're going to get 1.5 heads. To find the variance, we need to find the summation of x squared p of x, then subtract the mean squared from it. The variance is equal to the summation of x squared p of x, which means I need to add this column. And that gives me a value of exactly 3. So we're going to take 3 and then subtract the mean squared from it, and that's going to be 1.5 squared. And this gives us a variance of 0.75. So our mean is 1.5 heads. Our variance is 0.75. We can take the square root of both sides here, and so the standard deviation is the square root of 0.75, and our standard deviation is equivalent to approximately 0.866. Now we did this problem by hand to show you how it would work, but you don't have to do it by hand. You can use a calculator to do these problems, and a link will be provided on your homework assignment so you can do these problems with a statistics calculator. We will look at the interpretation for the 3-coin toss. Though 1.5 heads cannot occur, it is the long run or theoretical average. We are trying to say that in the long run, you're going to have an average of 1.5 heads because you're tossing a coin 3 times. It makes sense that half of the outcomes will be heads and the other half will be tails. Sometimes we refer to the mean of the probability distribution as the expected value of the probability distribution. That is, the expected value is the average in the long run. Expected value is used in gambling, insurance, and other areas of statistics. If the expected value is negative, that means we're going to lose money in the long run. If the expected value is positive, that means in the long run we will expect to make money. Example, from past experience, the manager of a local music store knows the probability of buying 0, 1, 2, 3, or 4 CDs. The probability are as follows. Find the expected value of someone purchasing a CD. Remember, the expected value is equivalent to the mean, and that was equal to the summation of x times p of x, just like before. All I need to do is multiply the first column times the second column, and we'll get the x times p of x column. 0 times 0.3 is 0. 1 times 0.3 is 0.3. 2 times 0.25 is 0.5. 3 times 0.1 is 0.3. And 4 times 0.05 is 0.2. To find the mean, we'll just have to add the last column, and we get a total of 1.3. The total is 1.3, and so we have an expectation that we will sell 1.3 CDs for each customer on average. In the long run, we'll expect to sell 1.3 CDs per customer on average. Now, it's not possible to sell 1.3 CDs to a person, but we're talking about the long run average. Example, suppose you buy one ticket for $1 out of a lottery of 1,000 tickets where the prize for the winning ticket is to be $500. What are your expected winnings? The key phrase here is expected winnings, so I know we're going to find the expected value. For this problem, we'll use a table. And recall our formula is the mean is equal to the summation of x times p of x. And in this case, we have a couple of different scenarios. I can win the lottery, or I can lose the lottery. If I win the lottery, I will be making a certain amount of money. And how much money will that be? It is actually $499. The reason we only made $499 is because we paid $1 for that ticket. So overall, our profit is merely $499 and not $500. If I were to lose the lottery, I will lose $1, so we'll use -1 to represent a loss of $1. What is the probability of winning? We bought one ticket out of 1,000, so we have a 1 in 1,000 chance of winning the lottery. Now the complement of winning is losing. There will be 999 losers out of 1,000. And I did that by subtracting 1 minus 1 over 1,000 to find out how many people lost the lottery. Now we can multiply x times p of x. 499 times 1 over 1,000 is 499 over 1,000. -1 times 999 over 1,000 is equal to 999 out of 1,000. And now I can find my total. Now remember, the total is going to be the sum of the column x times p of x. And we get the total is negative 0.5. Now since we're talking about money, I'm going to change this to negative $0.50. So in the long run, if we continue to play this lottery, we will expect to lose negative $0.50 or 50 cents. This tells me we probably should not play the lottery because the odds are against us. Example, a game of chance at the fair has a box that contains 5 $1 bills, 2 $10 bills, 1 $20 bill, and 1 $100 bill. You reach in and pull one bill out. It costs $15 to play the game. How much should a player expect to win or lose at this game of chance? Let's do this problem again with a table. There is a couple different scenarios. I can pull out a $1 bill, a $10 bill, a $20 bill, or if I get really lucky, I can pull out a $100 bill. Now remember, we're going to be paying $15 to play this game. If I pay $15 to play this game and pulled out a $1 bill, I'm going to be losing $14. I lost $14 because I paid $15 but only got a $1 bill back. If I paid $15 and pulled out a $10 bill, that means I lost $5. If I'm lucky and pull out a $20 bill, that means I made $5 because I paid $15 to play the game. And if I get really lucky and pull out a $100 bill, that means I made $85 because I paid $15 and got back $100. Now let's find the probability of pulling out a $1 bill. There are 5 $1 bills, and if you add up all the bills, you get a total of 9 bills. We know there's a total of 9 bills, and so we have a 5 out of 9 chance of getting a $1 bill. There is 2 $10 bills, so we have a 2 out of 9 chance of getting a $10 bill. There's only 1 20, so we'll have a 1/9 chance of getting a $20 bill. And there's also only 1 $100 bill, so we have a 1 in 9 chance of getting a $100 bill. We will multiply the x and p of x column to get our last column here. So we have negative 70 over 9 by multiplying negative 14 times 5/9. Negative 5 times 2/9 is negative 10/9. 5 times 1/9 is 5/9. And 85 times 1/9 is 85/9. We can find the total with our calculator. And since we are rounding to the nearest cent, we're going to get 1.11. So the average in the long run, or the expected value, is $1.11. If we continue to play the game, we will expect to make money off this game of chance. I would be playing this game every single day, all day, because I know the odds are in my favor.